مرحبا مساء الخير. إن شاء الله تكونوا ارتحتوا للغداء. Let's all sit down please. لنجلس جميعا لكي نبدأ السيشن.
لنبدأ يلا. شكرا لكم. عشان البرنامج ما يتأخر. So that the program moves smoothly and is not late, we can start, I think, with the number of people we have in the hall. And when they start speaking, maybe they will rush. Monsieur Baptiste, would you like us to begin? Okay, just wait until I introduce you. Let me give you your grand opening, your grand entrance. All right. Good afternoon, everyone. أهلا وسهلا بكم مرة أخرى. So I welcome you back at the main hall. I hope you're having a good first day at Aidtsec, the Artificial Intelligence, Defense Technology and Cybersecurity Conference. I think after lunch I've slowed down just a little bit. My apologies. So our next session is a keynote address from one of our silver sponsors from Microsoft, Middle East and Africa HQ. We have with us a gentleman who's going to talk about AI in defense applications. His name is Mr. Baptiste Kazagou, who is working in public safety and national security domain at Microsoft Middle East Africa HQ. Let's give him a hand. It's all yours, Mr. Baptiste.
Thank you. Your Excellencies, distinguished guests, good afternoon. It's an honor for me to be there in this country who has seen a millenary of military history. I'm Baptiste. I'm working for Microsoft as head of defense and security solution for Middle East Africa. My background is in the military. I was an officer in the French army during 10 years. And since 10 years now I am advising military and Ministry of Defense in the field of technology. So today I will explore with you the current artificial intelligence application in defense and try to extract some lessons learned from this early stage period of artificial intelligence usage in defense. So let's start with a quick look at the global security landscape. As defense professional yourself, you follow like me the trends that are shaping our industry today. All these threats and trends have one point of confluence, the constant need for innovation and technology edge over the enemy or the potential adversary. It has always been true in the military, so nothing new, but we face an acceleration of technology impact in the armed forces due to the dependence of our society on the information and communication technology. So information warfare, cyber warfare, PSYOPs, intelligence, computing power, encryption, and soon quantum computing, all those new buzzwords are really shaping the defense industry today. So those trends, you know them, terrorism, hybrid warfare, that extend to new cyber domain, the high-intensity scenarios that are coming back, regional instability, race to space. So all this is really shaping today the future of the defense industry. And can we really predict what the future will look like? If we try to picture the most cutting-edge trend in the next 3 years, 5 or 10 years, what do you see? In fact, it's very difficult to predict what will be the next big thing. And all those unpredictable trends really challenge us and challenge our thinking. What we know is that the digital era is here. And it's irrigating all the military system today. So before, we were talking about this network-centric warfare, which is a concept coming from NATO, and today it's still very true. But the data itself have taken over this concept of network-centric warfare. And now it is really the information, the data itself, which is at the center of our organization in the defense world today. And it has been possible thanks to an unprecedented usage of commercial technologies. Until recently, innovation was driven by defense. So you can think about Internet itself. Internet is the daughter of this DARPA project called ARPANET in 1969. But today, let's say since 20 years, 30 years, we have seen really transformative, disruptive technologies coming from the commercial side, breaking through the gate of military procurement, forcing Ministry of Defense worldwide to adjust themselves and make some leap of faith towards commercial technologies. So, moreover, these technologies are often cheaper, even they are not all ruggedized according to military standards. So you can think about drones, about personal computing, smartphone, mixed reality, sensor, biometric technology, you name it. And it has an impact, of course, on the data, because there will be, and there is actually today, an overwhelming amount of data available to a modern defense force. And this is growing. When we think about the Internet of Military Things, we anticipate 80 billion connected devices by 2025. And we are talking about data in zetabits. So it's really hard to even wrap our heads around how much data is available for processing and exploitation. Smart sensor, hybrid cloud, connected device are breathing new life into every single industry on the planet. And everything and everyone is a sensor today. So simultaneously, you have hybrid cloud, which not include just traditional data center and the public cloud, but as well include air-gap capabilities, on-prem infrastructure, and computing devices all the way out at the tactical edge, on the battlefield. And this is very interesting. The intelligent cloud is all about ubiquitous computing, enabled by the cloud and powered by artificial intelligence. So in this way, we refer to Azure as a world computer, powering every type of intelligence, application and system for our customer. So this intelligent edge is the continually expanding set of connected systems and devices that gather and analyze information close to the physical world where the data reside. So, why artificial intelligence and why now? We believe that artificial intelligence is essential to helping customers to optimize operation in a data-driven manner. And there has never been a better time for it, given the confluence of big data, the global movement towards a cloud-enabled compute posture, and the need for data-driven mission and business optimization. So we view the cloud computing as a backbone of the modern defense posture, and artificial intelligence as a brain that allows computers to reason, to synthesize data, and to solve complex problems in a manner that simulates human intelligence. And it has been said this morning, this is not about using artificial intelligence and machine learning to replace the human element, but rather is about augmenting the human element by providing computationally supported decision and capabilities that are both data-driven and transparent. This allows defense forces to optimize operation, to improve readiness, to gain information superiority, and accelerate the OODA loop, all critical to successful defense posture. So, at Microsoft, we are deeply committed to artificial intelligence research. And we make market-leading research investment across a number of domains annually. And this has led to an explosion of artificial intelligence breakthrough, as you can see, especially to achieve or exceed human parity across a number of artificial intelligence domains in the recent years, with proven results across industries, and the research continues, of course. So it's not to pursue artificial intelligence to beat humans at games. It's not about that. It's really to empower every person, every organization, that people to build, tools with artificial intelligence so they can go on to solve the most pressing problems of our society and our economy. If we look at the different domains of artificial intelligence in defense today, we can list actually a lot of domains. Of course, predictive maintenance, sentiment analysis, document classification, speech-to-text, threat and hostile activity detection, including in cybersecurity, change detection, facial recognition, multi-intelligence fusion, satellite images, radar, human intelligence fusion, autonomous route planning, modeling, simulation. So a lot of domains are actually addressed today by artificial intelligence by a way or another. And all the scenarios need the same element to be successful artificial intelligence use case. The first element is first the data, and lots of data. So it means you need the actual sensor to collect it on your military system or on your military platforms. You need the connectivity, and in the military the connectivity is a challenge because you have constrained bandwidth, because you have jamming. So you need a robust network, obviously, based on software-defined radio, based on satellite communication. So connectivity is a challenge. And you need the data lake to collect and to fusion this information. So first, data. Second element is trend algorithm. And in fact, we have experienced that generic algorithms are very difficult to customize to the defense world. The companies who are doing well in artificial intelligence algorithms are very specialized per industry. Those who are doing predictive maintenance algorithms are not the same who are performing facial recognition, and they are not the same to those who are doing only geospatial intelligence. So you need to be very focused, and you need, of course, a team of developers that really understand the business is operating in. There is no magic. You need training at scale to improve your machine learning model and computing power. And finally, the third element is definitely the integration capability. Because if you how to bring the outcome of artificial intelligence into the system you are operating in. So I mean the C4I, I mean the battle management system, the intelligence system. So instead of recreating another silos of information, you need really integration capabilities to make sure the decision making is supported by this artificial intelligence outcome. Let's take a look today at some examples that we have seen over the past couple of months. Let's start with, for instance, the mixed reality for soldiers, with this HoloLens mixed reality helmet. I have seen actually some nice development over the HoloLens technology in the corridor, so quite interesting to see how it spread worldwide. So the US DoD decided after 3 years of testing to deploy mixed reality helmets for the Army. So this project led by Microsoft with more than 10 defense companies is combining gaming technologies, so again commercial technologies, with artificial intelligence from cognitive services, so computer vision, speech-to-text, translation, transcription, anomaly detection and other, and as well multiple sensors such as infrared, luminous intensity, thermal imager. So this future soldier program has been designed to provide a technology edge in combat for US soldiers. So it is a concrete application, still in development, but an amazing evidence of what can bring artificial intelligence today in the defense world. Another example, which is quite scary for me actually, is loitering ammunition. So loitering ammunition is those munitions who have been used in the various very recent conflicts, from low to medium intensity, let's say, and it really questions ourselves about the chain of command and the necessity to have human in the loop at any time. It also questions the ability of the army to understand and master such algorithm instead of being dependent from a supplier of another country who provide actually such munition. So those key ethical questions should be at the center of the discussion today within Ministry of Defense, who are procuring such external technologies, those kind of foreign technologies, without having internally enough skills, enough teams to understand what they are buying, what they are using. Drone swarm. So drone swarm, you have two faces of those drone swarm. You have the nice drone swarm in Dubai, in Beijing, doing some nice show. And you have also the drone swarm for military attack of dozens of coordinated of drones to overwhelm air defense radar and anti-drone system. So the attacker launches its suicide drones, betting on the numbers, on the mass of drones versus the air defense capability. So this is a low-cost approach, very effective, even with the air defense capability quite strong. So we have seen again this tactic deployed in the region and not very far from here. On the opposite, you will need artificial intelligence detection capability to detect those mini drones and react quasi-autonomously to a drone swarm attack. So after the detection combining radio frequency finder, holographic radar, speed will be very key. And again, artificial intelligence will be a central building block to build such anti-drone system. Another domain is geointelligence fusion. So it's currently really focused in lots of countries to leverage all the space capabilities that the Western world and others are developing. And with the amount of videos and the images produced by drones in real time, with the refresh rate of the satellite today, especially those with a low orbital trajectory, you cannot really rely on human capability to detect changes on the satellite images. So you need to have artificial intelligence to really improve your detection and to really have a sense of the situational awareness that you want to create for the decision maker. And the customization and the training of such algorithm is quite tough to achieve. And you need focus, and you need a huge computing power actually to really train the right algorithm to do a geointelligence fusion. Finally, of course, the usage of artificial intelligence in cybersecurity is growing to detect anomaly in pattern, in behavior, to predict attacks, but as well to simplify all the work done by the cyber analyst with an artificial intelligence triage of the large amount of data that the Security Operations Center has to tackle. So just some example to illustrate today the development of artificial intelligence in the defense. Let's maybe take some use case, like for instance predictive maintenance. So predictive maintenance is a great use case for leveraging artificial intelligence to optimize operation. So with predictive maintenance, you can really use sensor data for equipment, health monitoring in real time or near real time, coupled with machine learning models deployed to identify performance trends, get insight into reliability of assets and platforms, identify faults and predict impending issues, so you can proactively mitigate failure and perform maintenance in a data-driven fashion. So this conditional maintenance is often more effective than traditional scheduled maintenance and much more efficient in terms of managing parts inventory and supply chain as well as management of resources. It's also really happening in the defense industry. So you have, all the big defense integrators such as Airbus, BAE, Raytheon, who are using mixed reality today to design system to check quality of the equipment, or to train people remotely thanks to this mixed reality technology. Another use case close to the geointelligence fusion is, of course, the situational awareness and decision-making assistance. So it's a good use case because it's all about enabling a sense-making approach to mission and defense operation by leveraging artificial intelligence. So you need to combine data from multiple sources and correlating events in real time. Intelligence organization and defense forces are able to get a more complete picture of the situation, including related threats, geographic, weather condition, location of friendly force, etc. This enables more effective coordination of resources. AI-enabled decision support in extremely complex situations. And it's better, of course, for the situational awareness of the troop on the theater if you enable this cloud to the edge capability. So data fusion is a big part of this, and many of our defense customers have an overwhelming amount of data at their disposal from disparate sources. So ground sensors, satellite imagery, you name it. And as the situation develops and data related to the situation is captured, correlated and fused across these various sensors, it can be processed using artificial intelligence to help commanders and troops to generate course of actions and make decisions accordingly. My last case is modeling and simulation, and it's where artificial intelligence is very powerful as well. You can think about digital twin today. Digital twin is one example of modeling and simulation where you marry the physical and the digital worlds for platform, resources, or other environmental conditions. This is a core element of the digital engineering today, which helps to build defense systems in a better and a more modern fashion. So teams can design, build, and test digital model before even physically building the capability. And they can introduce any number of real-world conditions into the test and simulate how the system will respond. So this is foundational to future defense system and platform, and it pays huge dividends over the entire system life cycle as well. So modeling and simulation is also quite useful in a number of defense use cases as well, including wargaming, including simulation, digital training method, very close to the gaming industry actually. So our approach, as you understood, the complexity of diffusing this artificial intelligence into the different level of defense organization, our approach is to democratize the usage of artificial intelligence and to have this kind of artificial intelligence for everyone approach. This means making artificial intelligence accessible and valuable for every organization, not only for specialists, and perhaps for every person within an organization with a low-code, no-code approach, for instance. So our approach is going really from the bottom to the top, using first powerful infrastructure and hardware. So you have, to do some advanced artificial intelligence, and it will be even more true with quantum computing. You need more specific hardware at the CPU, at the GPU, at the hardware level to perform those advanced calculation. And you need as well to have some specific hardware to enable some tactical cloud activity, for instance. And the more you go towards, I would say, the top of the approach, the more you enter in a simplification of the artificial intelligence, meaning that you have out-of-the-box capability, especially for the cognitive services. So cognitive services, it's really to process, for instance, computer vision, speech-to-text, languages, anomaly detections, So those out-of-the-box capabilities you can really customize with API and development kits and provide capabilities to everyone, I think. And it's important to do it across defense organization. So from non-technical workforce up to the developers. And you need to spread this culture across your organization by improving the skilling, definitely, using off-the-shelf algorithm, but as well customized algorithm when it's needed. And we will see I would say this approach allow a better understanding and a more responsible approach across the organization. So we talk about bringing the cloud capability and some artificial intelligence capability to the edge. At Microsoft, what we really try to do is to provide this end-to-end experience, especially for defense organization, from the IoT devices up to the hyperscale commercial cloud. So it means we have an hybrid strategy, recognizing that all the data cannot go to the commercial cloud, and it's why we have developed ruggedized tactical cloud to bring it to the battlefield. So, what defines an artificial intelligence ready defense organization? So first, definitely, data at the center is a culture. And it's essential to foster this artificial intelligence ready culture, because that is what will truly drive artificial intelligence adoption and usage. An artificial intelligence ready culture encourages continuous learning through a growth mindset. It taps the creativity of the entire workforce, not just the technical roles, and it starts with data at the center. So this is probably one of the first key elements. The second element to really start working on artificial intelligence is a digital backbone. So it's really hard to truly leverage artificial intelligence without first having the right infrastructure, tools and policy in place to host this data culture and to start collecting those data needed for the artificial intelligence use case. Third one is definitely the workforce. So we talk about the culture, but this is important to democratize artificial intelligence, even in defense, to make it accessible to everyone, and especially for those who are not data scientists and not software developers. Otherwise, it will be very tough to illustrate and to demonstrate the value to the organization. And finally, responsible innovation. I think it's very important for a defense organization to start building its own skill internally, to at least have an understanding of those concepts. Because we talked about it this morning as well, it's very important to understand why the artificial intelligence algorithm has been crafted like that, why it is understandable, and to have some ethical consideration when we use those tools today. So this is quite important as well for a defense organization, because most of the MOD today will probably rely on foreign technology and will need a sense of understanding of what's going on inside the system that they will buy tomorrow. So the next steps are quite straightforward, I would say. I think it's important to start collecting the data, to have this right digital backbone, and to start collecting the data, because otherwise we cannot really talk about artificial intelligence. And to start, a proof of concept is very hard without the data, and it failed quite frequently recently for some defense organizations because they are not ready. They don't have enough data. A second step is definitely to have an artificial intelligence and a cloud strategy, and to be clear about it, and to really define what could be the good proof of concept, what are the data we want to use, what are the classification level we want to address. So all those questions are very key in the defense to start working on artificial intelligence. Team skilling is definitely key. Every organization needs to have an in-house pool of experts to understand this concept. And again, a responsible AI approach and strategy to be sure we can develop and use algorithm to really understand some ethical concepts related to artificial intelligence, and definitely as well to address all the sovereignty issues that can happen by leveraging third-party algorithm. So this is basically the principle for responsible AI that Microsoft has developed. So reliability and safety, fairness, transparency, privacy and security, inclusiveness, accountability. So all those principles are very important in order to complement human and not replace human with understandable artificial intelligence. And it is, I think, an approach that is quite fair, and I think we can add to those principles for a country as well some sovereignty consideration that are quite, I would say, key when we are addressing artificial intelligence development within the Ministry of Defense. So this is the end of my presentation. Thank you very much for your attention, and I am at your disposal if you have questions. Thank you.
Well, I don't think we have a question-answer format, but Mr. Baptiste is available. If anybody has a question or a comment, you can grab him and talk to him about anything you like.
Thank you.
So thank you very much. Thank you, Baptiste Kazagou from Microsoft Middle East and Africa HQ. Thank you, sir. Thank you very much. All right. So next up, we have a plenary session, Nadwa, on the topic of swarm intelligence. Swarm intelligence. I invite the moderator of this session, Dr. Hussein Al-Natche, Chief Data Scientist at Beyond Limits. تفضل Dr. Hussein. Hussein is one of the first Jordanians to have a PhD in AI. I also invite his three panelists. You can grab your seat if you want. Mr. Amjad Abdallah, CEO of Beyond Limits. We're honored to have you with us. And Professor Ahmed Beni Yunus from the Mechanical Engineering Department at Al Hussein Technical University HTU. أهلا وسهلا دكتور. And Dr. Naila Al-Madi, Associate Professor from Princess Sumaya University for Technology PSUT. أهلا وسهلا دكتورة. شرفتونا. Well, I think we have here on stage a lot of brain power in AI and engineering. So I leave it to you, Dr. Hussein, to extract the value from them. Thank you very much. تفضلوا.
Thanks a lot, Zaid. It's also a pleasure. Can you hear me?
Yes.
Hello? Yeah.
Keep your mouth close to the mic.
A close friend of mine, and I'm very happy to see you in this event. Thank you very much for the introduction. So good afternoon, everyone. It's a pleasure and privilege for me to welcome the panelists this afternoon. And thank everyone for your interest in this, I would say, very interesting topic, and as a topic that has a very potential, if not already, in the defense technology and cybersecurity. So I would like first to introduce that, but already they did. Thank you very much. But I will give maybe a quick round table for our panelists to introduce themselves. Maybe I'll start with Dr. Naila. If you can tell us about yourself, your background, from where you come, and
Thank you, Dr. Hussein. My name is Naila Al-Madi. I am an associate professor in data science department at Princess Sumaya University for technology. I don't know if the voice is clear, or do you have? Okay. So this is about me. I'm in data science department. Dr. Ahmed.
Thank you.
Okay. My name is Ahmed Bani Younis. I'm associate professor in the mechanical engineering department at Al Hussein Technical University. I'm also the founder and director of the spacecraft platform for astronautics and celestial illumination at San Diego State University. My research interests actually in the autonomous vehicles, guidance navigation control, and space systems. I'll be talking more probably about AI-based techniques and learning-based techniques, algorithms, and how those are implemented in space robotics.
Thank you very much, Dr. Ahmed. You have fans in the audience. It's a privilege to have you, especially an expert in the domain. And last but not least, Mr. AJ.
AJ Abdullah, CEO of Beyond Limits, serial entrepreneur, launched several companies in the intelligent systems, bio-inspired AI, and I'm really happy to be here.
Thank you very much, everyone. It's really a privilege for me personally to have you here. Again, this topic is actually, it might be kind of technical, deep technical, but still, I would say, very interesting and important topic. So we'll try in this panel to give awareness about it and shed the light in its importance and the potential applications and also defense technology. So as an awareness level, I would like to start with Dr. Naila, if I may, to tell us more and tell the audience if you have like a kind of, I would say, scientific definition of what is a swarm intelligence and under which field in AI is it?
Okay. So swarm intelligence is a nature-inspired algorithms. It comes from, it's composed of simple individuals that interact with each other and interact with the environment to build a group behavior, to find solutions for complex problems or to enhance or improve the performance of some other algorithms like machine learning or neural network or other algorithms. Its advantages come from that you can formulate it to solve multi-objective problems or to have to find a solution, optimal or near optimal solutions for multimodal or global, or to find a global solution for complex problems. So maybe this one. For the field of AI, it comes under the searching because the AI has many fields like supervised, unsupervised, and have the machine learning, have the knowledge representation. So the swarm intelligence come under the searching field.
Very interesting. Thank you, Dr. Naila, for these insights. Professor Ahmed, if you want first to add more about the definition, and then I want to ask you, could you share with us some of your maybe experience in applied research when it comes to using swarm intelligence, and if it could be applied in like other things than search, optimization, simulation. Thank you.
Yeah, I think the definition is clear how to bring coordinated agents together to basically contribute to certain missions. For the research, actually, as a director of spacecraft platform for astronautics and celestial illumination, that makes space. So if you didn't get anything there, so what we are trying to do is to prove that the Earth is not flat. That's basically one aspect. The idea behind using multi-agents or swarm intelligence on utilizing robots, for example, come from how to improve the level of autonomy for individual robots to improve or to achieve certain missions. Now, the research actually that I've done starts from ground-based, aerial-based, and space-based agents. So coordination between multi-robots. I can highlight some of those. I cannot tell everything because I've done this for over not many years. I'm not that old, but basically for the first one that I started is using CubeSat-based swarm techniques to search for water in the moon. This research actually partnered with the Space Metro in San Diego. They helped me to formulate how to use CubeSat missions. When I say CubeSat, it's basically a small satellite that has size of 10 centimeter by 10 centimeter by 10 centimeter. And using multiple CubeSats, instead of using giant big satellite, actually provides a way to navigate and provide more maneuver aspects on the way that they move and they deliver. So that was one of the first mission. The second, actually, it was in response for a call by FEMA in using swarm VTOL drones. VTOL drone is the hybrid drones that takes off and lands vertically but has wings. So using a bunch of those, as around like 50 plus, the idea was formulated to use those to carry water and for firefighting. So this drone has a capacity to carry about like 70-pound gallons of water, and they go together searching for the basically the area of fire and try to attack the fire. They learn at the same time about the fire incident, how the fire propagates with time, and they try to attack, based on the conditions, the environment, how to improve the mission, and plus provide zero fatalities, like get the human away from that. The other one is coordination. So it's a space-related project, actually, using, you guys have heard of the JPL drone. So using the coordination between a ground-based vehicle with aerial vehicles like a drone. I know like flying drones in Mars is not something, it's a lot of challenge with the thin atmosphere. But also utilizing those because, drone can have a more accessible view than ground-based techniques, because fly high, you can see more, then you can't tell who's down in the ground to deliver or to do certain missions. So this, I have done this in the lab, not only simulation, so we have also experiments. So we design low-cost experiments to emulate these missions. So we build microgravity, dark space, ground risk reduction experiments in the lab, actually, to emulate and simulate, to demonstrate these missions and let the students learn about it and validate, some of these algorithms.
That's really, really interesting. And tell us that how much is this new science is applicable, and starting from space. And that maybe led me to ask Mr. Edge, because I know that Beyond Limits also come from a heritage of GPL, mentioning by Dr. Ahmed. So can you tell us if, like in industrial AI, what are like maybe different at large, like if we can step back and talk about optimization in general, what kind of algorithms similar to swarm intelligence that Beyond Limits uses to tackle industrial problems, and if there is any examples you can share with us?
So there are many forms of optimization algorithms. You can take, for example, existing processes and apply them to a model and end up with a more efficient model. Machine learning, for example, is a classical technique that we use to solve classification problems. And basically the way it works, you train the system or the AI system based on data, and that's very, very useful. What we do at Beyond Limits is we do that, and in addition is we try to train the system based on educate the system. So it's not just trained based on experience, but also based on education. That could be, again, from textbooks, from workflows, computational, formulas, principles, whatever the case might be. And what we found in many applications that by utilizing this hybrid approach, you actually can decrease the amount of training required for the data, and that's very important, you know, and it will reduce the cost. We're using that, for example, in oil exploration, in well health management, where we actually are teaching the AI systems, you know, feeding them from data that's coming from all different kind of sensors, in addition to what experts in the field over decades have accumulated. And we've noticed that the models, the output models that basically result from this hybrid approach is a much more efficient models than just from a standard, a single approach.
Very interesting. Thank you very much for sharing this with us. Maybe I go back to Dr. Naila. Now we have like a good base of what is swarm intelligence. But maybe for some of us or for the audience, it's not very clear what is, because for us, when we hear AI, first thing comes to mind is machine learning.
Yeah.
So how like maybe we can differentiate better between the two fields, and what's the main difference between the two things?
Sure. Machine learning is making the machine intelligent to think or to act like a human. And we have different models like supervised or unsupervised to build this model to predict maybe for the future or to analyze the situation that we have based on the data that we have from now. But the swarm intelligence is based on searching for the best solution or the optimal or near optimal solution based on the problem that we have. So they are different. In the swarm intelligence, we just search for the solution based on the population and interaction between these solutions. And the result is a solution or a suggestion for a solution with a good performance for the problem. However, machine learning, the product at the end is a model that helps us to use this model in the future or to learn from the data that we have. It's important also to know that nowadays we are using swarm intelligence to enhance machine learning. For example, in my research, I use the swarm intelligence to enhance the neural network, to suggest the best parameters for neural network, not to let the neural network do grid search or to work for a long time to find the best parameters, but we can use swarm intelligence. Also, we can utilize the swarm intelligence to find the best features for the machine learning to work on it, not to give it all the features that we have. So this is the main difference from my side.
So they help each other in a way, and maybe swarm intelligence is helping machine learning.
Yeah. Also, for me, I did almost 2 papers that use swarm intelligence to suggest a good clustering algorithm or to work as a clustering algorithm, and to suggest a clustering model at the end. So you can formulate the swarm intelligence based on the problem or based on the problem that you are working on, or you need a solution for it. So it can work as a machine learning at the end.
Very interesting. I would like to stay with you. You mentioned that swarm intelligence is a part of nature-inspired intelligence. So what's the difference between swarm intelligence and other algorithms like genetic algorithms, multi-agent systems, and
I think genetic algorithm or genetic programming, they are from evolutionary computations. They are based on the chromosomes and how they interact with each other to build the new chromosomes. But the swarm intelligence, it has a population. Each one is a solution, and they have this velocity and update on each solution based on the equations that we have. Also, the genetic algorithm, let's say the swarm intelligence, we have different algorithms. One of them suggests the shortest path, like the ant colony. It's from based on the ant colonies, how they find the shortest path. And we have, for example, the glowworm swarm optimization or the bee colony swarm optimization. Each one of them has or suggests a solution based on different infrastructure.
In terms of like accuracy and performance, time consumption for such algorithms, because when it comes to like bigger type of applications and dealing with big data, you think swarm intelligence can have a competitive advantage over complex algorithms like reinforcement learning or deep reinforcement learning? Or how do you see that?
Yeah, regarding accuracy, I think it's based on the problem itself. We can't say one is better than the other because for each problem we can use different algorithms to find the best solution. But regarding the computation time, I think the swarm intelligence needs a lot of time because it's an iterative, like you do generations to let the individuals interact and find the final solution. However, with the Hadoop and the big data and this infrastructure, we can use big swarms and find the best solution in a very short time. So we can utilize the improvement in the technology to update or to improve these algorithms.
Thank you very much. I want to switch to Professor Ahmed. We saw in the keynote just before this swarm drones. What are other like potential applications do you see in defense technology using swarm?
Okay, I think the previous lecture took and highlighted a couple of different principles and venues for swarm drones for defense, but you can extend this to multi-direction. So basically, using the drones for defense is not going to be subjective to a certain mission. It would be like multiple missions with multiple payload. I can recall one of the projects that I've done back on using swarm drones for surveillance and detecting, any shooting events, for example. So the idea of utilizing drones basically, provides the capacity that the drone would give to minimize the number of fatalities, as I mentioned. You need to save army as much as possible. You need also to tackle, certain critical targets with minimum loss. So that's the idea. So if you are able to develop a net of multi-drones or multi-robots, not necessarily to be like drones, to tackle a certain mission, that's going to be a successful defense solution. I cannot suggest certain ideas, but I can highlight you there are some basically mission-oriented goals that each mission has specific goals and these specific requirements. So you design the swarm based on what you need to do. Okay, so that's how the defense can be extended to that level. There are many funded research and technology advancement in this particular problem. If you look around the world, you can tell how the drones technology or swarm intelligence technology has been implemented on multiple defense solutions, and it's being sold in different exhibitions. So you define the payload that you have, you define the mission that you need to do, then you can design, build, and fly swarm intelligence to achieve these missions.
Very interesting. And what about, do you think, again, since it's a nature-inspired and collective intelligence type of maybe communicating between agents, do you see this is applied to have like a communication protocol among a group of robots, maybe?
Yeah, of course, robots talk to each other. It depends how you design the central thinking or central control or decentralized control depends how you handle it. But robots definitely talk to each other. They understand each other. They think as we think. That's sometimes we call it like social agent or social drone. So they speak, they think, they behave. They do object avoidance. They do tracking for a certain target. They change the target, and they deliver also goods for the mission. So the communication basically is challenging because you have to have a secure anti-threats communication system, because you don't have like build nice technology, spend like millions in it, and eventually some talented guy who's able like sitting at home and attack it, and you're going to be at risk. So basically, the way that these agents communicate between each other should be secured enough. And with all the cyber threats that could achieve, it has to have like a certain barrier of protections for that. The other challenge actually is related to the level of autonomy, because sometimes those individuals will need to perform certain missions, and they have to decide. For example, if you think about like a flying swarm intelligence over like neighboring planet like the Mars. It's going to take like 30 minutes or more, or sometimes until we communicate from the ground station from Earth to Mars, because of the delay and latency in the communication. So we need to have like some autonomous thinking where the agent itself has sensors and it has a brain. So based on sensors, those are trained to deliver certain missions or to perform certain actions based in the environment and based on the event. And that's what the data learning or learning-based techniques implemented for that.
Very, very interesting, Dr. Ahmed. Thank you for sharing all of these insightful information. I want to go back to AJ, and Beyond Limits were pioneering like commercializing AI technologies and like unconventional ones to real life applications and unsolvable problems, I would say, even in Earth. And that was a good example that you mentioned in the beginning about cognitive AI and symbolic AI. Now we're hearing about swarm intelligence, which is also something been researched on in NASA. Do you think that there is a potential applications for this technology in your current product lines or future application?
I do. We are very excited, again, as I mentioned, about this unified approach that we call cognitive approach to solving complex problems. I talked this morning that, with the classical narrow AI approach, we were able to basically solve many, many problems and solve them very, very efficiently. But we're running into kind of a different class of problems that, require not just data, but basically also leveraging the human knowledge and human engineering. And it really allowed us to kind of solve different class of problems. In addition to that, at Beyond Limits, we've actually built a technology called Brain Trust. And Brain Trust is a collaborative-based problem-solving framework that basically distribute expertise across experts ecosystem. So the idea here is if we can have expert systems in many fields, we really feel that the collective insight we're gathering from these different agents will really, it will collectively basically create a different insight for the business. We championed a new concept that we call the cognitive cooperation. We're working with a large energy company, and we're creating that concept. So the idea here with an energy company, they basically have different businesses. So, for example, they have upstream business where they're looking at oil exploration. They have a midstream business where they're looking at refining and formulation. And they have a downstream business where they're looking at distribution and shipping. And the idea with the cognitive corporation that you have these distributed AI agents, they may not know, the AI agents in upstream may not know anything about what's going on in midstream or downstream, but we're finding out that actually just based on sharing the data, that collective data, we're getting really actually insight that is basically provided to the executive management. This is a concept that we call the cognitive corporation. We're working with a large energy company. We're implementing that, and we're seeing some significant ROI, again, utilizing this cognitive hybrid approach with brain trust.
Very interesting. And do you see it as similar to other AI algorithms that are cross-cutting across different industries like healthcare, maybe fintech, pricing, bidding, things?
Absolutely. I think it can be applied to any business where you're managing large assets. In fact, it is ideal for these kind of businesses when you're managing large assets, whether you're in fintech or in healthcare. Healthcare, for example, look, I mean, ideally, I use this kind of maybe a simplistic example. But ideally, if you want to go to the hospital and you want to have an operation, ideal situation, you want maybe like 20 to 30 doctors operating on you. I mean, that would be the nice thing. You're in safe hands. Best surgeons out there. Well, that's not practical. That is just an expensive example. Well, to me, the next best thing is give me the best surgeon. Let that best surgeon be surrounded by collective AI agents that are experts in their field, deep in their field, and I want them to basically provide their insights, expertise, feedback to this brilliant surgeon. I actually think that's the way of the future.
Very interesting. Thank you very much. I would like to move maybe in a kind of a freestyle question answering. So I'll just pose the question, and anyone who would like to take it, please do. So what do you think the main challenges and limitations do you think that swarm intelligence has comparing to other AI algorithms? Why is it not that famous yet, like other algorithms? What's the limitation, the challenges in your mind?
Well, if I may, maybe I want to actually try it from not a technical point of view, but you're going to see more and more applications that are going to utilize swarm intelligence. So don't feel sorry for swarm intelligence yet. It's happening. I think today, again, if we look at the evolution of AI, the maturity of AI, what we're finding is what we call these stand-alone solutions, AI solutions. And what I mean by that is we're building AI algorithms that are good at solving a specific task. We've done that beautifully and very accurate manner. I think right now, if we're going to go to the next set of challenges, climate change, finding cure for cancer, space travel, you name it, okay? This approach is not going to work. We really have to look at network intelligence. We really need to push the envelope in that. So I actually see a very bright and strong future for swarm intelligence and network intelligence and this intelligence of network societies. I think it's going to be the wave of the future.
Interesting. Please, Rahman, if you want.
We still believe in science. So if they have like physical model, for example, we have a lot of motion. So if I can't find a balance between the model that I have, physical model, plus the data that I have, and wavelength, then I think I can have like optimal set of information, optimal solution for any any problem. So I don't just rely on the data itself. If I know how the data would look like, if I know the mechanism, the dynamic of any environment or any system, then I have some background about how the interaction between the states or the variables or the parameters in the system. With given more data, then I can make a balance between which one should I trust more, the data to build the model or the physical model to build the model. So both are weak. So I have to find a balance how to combine those together, integrate them, probably put more weight on another based on the environment, based on the conditions, and this would provide me with optimal solution, optimal set of solutions for certain problems.
Thank you. That shows a bright future for the field. Dr. Naila, in terms of maybe R&D and research for this domain, building on top of what's existing, what's could be future ideas to push the technology in terms of science research? Do you think, or in general, what's the future you see for semantic swarm intelligence? Sorry.
Swarm intelligence, yes. I think that the future is full of many ideas for swarm intelligence because the applications are a lot. It's now applied for UAVs, for example, for drones, not only for defense, for the simple movement of drones, for finding the best path or for path optimization, for obstacle avoidance, for many problems that still UAVs or drones still facing. We can use swarm intelligence to let them learn and solve these problems. Also, the swarm intelligence is now, if you just search on Scholar, Google Scholar, you can find a lot of research now on swarm intelligence. A lot of swarm intelligence algorithms are still being proposed through research papers. For example, you can find the dolphin algorithm, the elephant algorithm. They just get inspired from each animal or each insect موجود exist in this nature to learn their interactive with the environment and apply it for the computer science or the AI field. So a lot of research can be done.
Thank you very much. I'm not sure, Zaid, if we have time maybe open maybe for some questions from the audience, or are we should go to closing remarks from panelists?
I don't think we have a roving mic, but maybe we can do that because the hall, there's nothing happening after you guys in this hall, so maybe we can do that. تعطيني please hand mic. في أي حدا عنده سؤال أو ملاحظة? Anybody have a question or a comment? Anybody have a question or a comment? It is a somewhat technical subject.
I apologize for that, but it's important to raise the awareness at least.
This event is about AI technology, and swarm intelligence is a rising field in it, and so it is very important to talk about it. Also for the recording of the event, which will be seen by thousands of people. All right, so if we don't have any questions, do you have? Of course. Great. Students, I assume. Wonderful. All right. Thank you for your help. The microphone is arriving.
Hi. My name is Ruad Kilani. I'm a mechanical engineer at HTU. Actually, I have a question to Mr. AJ. You talked about educating the system besides training with AI. So I'm interested in this point more. Can you elaborate, what, let's say, techniques did you use to educate your system?
Very good question coming from a student. So we really use the same approach that we use with humans, the same processes in place. So Again, as I mentioned, when you're sending someone to college like you to study medicine or engineering, you basically are studying textbooks, you're interacting with your professors, you're interacting with your other colleagues, you're going to the lab. And if you're a doctor, you're going to become an intern, so you actually have real experience working with other doctors. And we really, it's a similar approach. For the last 4 decades, just to give you an idea, we've been sending spacecrafts to explore our solar system. That domain knowledge that we created for the first Viking one, which was a long time ago, compared to the knowledge base we've created, for example, with the Curiosity rover, is unbelievable. It contains, as I mentioned, physics models, formulas, algorithms. So we really use the same process as we use in terms of teaching humans, and that's why we call it human-like reasoning.
Wonderful. Thank you. Another question. Please introduce yourself.
Hello, I'm Hamza Mohammed from the University of Jordan. I'm an AI programmer, and I will ask the AJ professor for one question. It's a mini question. How can we improve an algorithm quantum to defense and cybersecurity in the future? Thank you.
It's a very general, I think, question. You got the specifics of it?
So I happen to believe that the future of cybersecurity is AI-based cybersecurity. And I'm sure there's a lot of experts. I'm an AI guy in the field say, well, today we have, AI-based cybersecurity, and that is true. I actually think this is just only the tip of the iceberg. I think the potential where we can take cybersecurity to the next level is just going to be phenomenal. So I am very happy and pleased, and we as a company, actually at Beyond Limits, we are implementing an AI-based cybersecurity solution. I mentioned this just incidentally at lunch today. We're a company, we're not a large company, we're about 250 employees, but we're focused on AI. On a daily basis, we get about 200 attacks from outside the U.S. on cybersecurity. So cybersecurity is very important. If a company our size gets 200 daily attacks, I can't imagine what the rest of the world is facing. We take it seriously. We have a team of 12 individuals. We're always focusing on how we can beat that hacker out there, how we can get ahead of him. And I think this is a field and a sector that you're going to see some exponential, great growth there, tremendous growth, and we're going to see a lot more in terms of AI tools that is going to be integrated with cybersecurity.
It's like a cat and mouse game.
Exactly.
Wonderful.
I believe also we mentioned quantum computing, right? So maybe
one of the professors perhaps would like to comment on that.
You want Dr. Ahmed to comment on that?
Please.
I think it's when it comes to heavily computational algorithms, like including Swarm. Do you think like such a new techniques like in quantum computing would accelerate and push the?
That's one of the challenges. We didn't answer the previous question, which was about the challenge related to handling AI-based techniques or cybersecurity techniques or swarm intelligence in general. So basically, one of this is the IT tech and computational burden that we have. So I think this challenge or the advancement in the swarm intelligence and learning-based techniques would need also advancement in the computational, let me call it like skills and also techniques / hardware. So without having that, then you're gonna still like you're gonna be smart, but you're gonna be like lazy to answer, which is not gonna be good, right? So you need to have like quick response, handling a lot of data. And I think most of the AI-based techniques or swarm intelligence they complain about or they check the speed up of the algorithms to make sure it would be reliable to be implemented and ported to a certain system. So yeah, the need for the quantum computation and speed up or fast, efficient techniques would be essential to have like very good advancement in the AI-based technology and smart intelligence.
Thank you. And I believe that you mentioned also using Swan and optimizing hyperparameters of big other machine learning networks.
I agree with Dr. Ahmed about the challenges, because the swarm intelligence is an iterative algorithm, and now we are having big data, so big data needs time, and the iterative technique needs time also, so this is the main challenge. But having the Hadoop and Spark and having this infrastructure now and being available for everyone will help us to speed up everything and have the solution in a very fast way.
Wonderful. Well, Dr. Hussein, maybe you can wrap up your panel, please.
Yes, thank you very much. Any final remarks from the panel? Please, Doctor. Yeah.
Probably I'll talk about one thing. I'm professor at the school at university. Probably we have the panelists here. My colleague here is from industry, also a professor from another university. So the way that we look at the problems and the way that we look at the vision would differ, but the objective is the same. For example, their products are solutions. Our products, where are my students? Can you please stand up? Those are products.
Please give them a round of applause. Thank you.
To develop algorithms for community. So that's basically what we do. For the same prime objective.
We need your products, by the way. So
yeah.
We have also PhD products here from Princess Sumaya University.
Also, let's give them a hand.
Great. So with that, I would like to thank again our panelists, and please join me and applause for them. And
thank you very much. Let's all thank our panelists. Thank you, Dr. Hussein Netche from Beyond Limits, and Mr. Amjad Abdullah, also from Beyond Limits, and Dr. Ahmed Bani Yunus from HTU, and Dr. Naila Al-Madi from BSUT, two excellent educational institutions that we are proud of in Jordan. شكرا لكم. أهلا وسهلا فيكم. شكرا لكم. تفضلوا. شكرا. So now, we have more sessions ongoing in other breakout rooms. This was the last session in this room. So we are staying, I think, until about 5:20 or 5:30. There's more things going on, so you can go there. And I thank you for attending the first day of Aidtsec. Tomorrow morning, I'll see you all here at 9 a.m. This is your presenter, Zaid Nasser. Wishing you all the best for today, and see you tomorrow at 9 a.m. شكرا لكم.